Welcome to this video lecture where we are going to see the solution of one-dimensional wave equation with zero initial velocity. In last class we had studied about the derivation of the solution using method of separation of variables, and now in this class let us learn a problem in one-dimensional wave equation having zero initial velocity. Now let us first take this problem. A taut string of length 2L is fastened at both ends. The midpoint of the string is taken to a height b and then released from rest in that position. Evaluate the displacement of the string at any point and at any time t. Now this is the problem. So let us now see how to solve this particular one. First, as usual, you write the one-dimensional wave equation, what we have derived using the method of separation of variables. So this is the one-dimensional wave equation where y represents the displacement. It's a function of x and t, where x is distance and t is time. And this is the correct solution of one-dimensional wave equation, which is c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. And the first thing, let us learn about the initial displacement which we need to derive in order to solve the problem. So this is the initial position of the string, because learn this string of length 2L fastened at two ends. So both the ends will be tied up. One end will be 0 and another end will be 2L, x equal to 2L, because here the length is given as 2L. And the midpoint of the string is taken to a height b and then released from rest in that position. So now observe, when you have a string of length 2L, what will be the midpoint? X equal to L, and it is taken to a height b. So like this, the string is taken and released from this position for vibrations. So will the string not be of this form? This will be the starting position of the string. So now let us see how to find the starting position in mathematical equation. So the initial position or the initial displacement of the string, which is denoted by y of x comma 0, because the word initial means at time t0, is given by this position OA and this position AB. So OA and AB. So this is the diagrammatic representation. And now let us see how to get the value of y mathematically. So for that, we need the equation of OA and the equation of AB. So let us see how to find equation of OA. This is the formula of equation of line joining two points, which you would have studied in school itself. Y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. Now OA, we need the equation of OA. So O is 0, 0 and A is, this is A. So what will be A? This distance is L and this distance is B. So the point A will be L comma B. So O is 0, 0, A is L comma B. So we call O as x1, y1 and we call A as x2, y2. And using this x1, y1 and x2, y2, substitute in this equation of the line joining two points. And from this equation, you get the answer for y as bx by L. Similarly, get the equation of AB. So now equation of AB, the point A is L comma B and the point B. What is the point B? Look at the picture. The point B will be 2L, because the distance is the length of the string 2L at this point. And of course, y coordinate is 0. So B is 2L comma 0. So A is L comma B. Since already we have used A here, L comma B as x2, y2, we are using the same form. And B is this 2L comma 0. So since this we have called as x2, y2, this we are calling as x1, y1. And as usual, the same equation of the line joining two points formula, use that. Replacing this x1, y1 and replacing this x2, y2, you can solve for y. And this will be the answer for y, b into 2L minus x divided by L. And you have two answers for y, one from equation OA and another from equation AB. Now look at the picture. From equation OA we get one answer for y. From equation AB we get one answer for y. But equation OA is from 0 to L. And the string will be in this form, AB form, from L to 2L. So now the initial displacement of the string is given as first form Bx by L from 0 to L. And the second form B into 2L minus x by L from L to 2L. So the first form 0 to L, the second form from L to 2L. So that is why we have y of x comma 0 in this form. Now let us take and write the boundary and the initial conditions of the problem. Since the end points 0 and 2L are fastened, that is given in the problem. What are the two ends? One end is x equal to 0, another end is x equal to 2L. At x equal to 0, there is no displacement. At x equal to 2L, there is no displacement. So at x equal to 0, there is no displacement. At x equal to 2L, there is no displacement. So y is 0. And the third value is initial velocity 0. Velocity means rate of change of displacement. So dou y by dou t. The word initial means time is starting time. So t is 0. So that is why you have dou y by dou t at t 0. This is given as 0 because in the problem it says the string is released from rest. The point from rest means initial velocity is 0. So that is why you have initial velocity 0. And the last point is initial displacement. Y of x comma 0 is given by this formula. This is the initial displacement which we have derived from this diagram. So this is the initial displacement. Now we have totally 4 boundary and initial conditions. So let us apply these 4 conditions in the correct solution one by one. So first condition is y of 0 comma t 0. Let us apply this. What is the meaning of y of 0 comma t 0? 0. Y of 0 comma t means in the place of x you have 0. So in this correct solution, put x equal to 0. So when you put x equal to 0 here, sin 0 0, cos 0 1. So what is the value of the first term? C1. Yeah, the value of the first term will be C1 into second term I am not touching. So the same term having t, and the condition says this is equal to 0. The condition says y of 0 comma t equal to 0. So equal to 0 we have to put. So from here we cannot equate a variable term to 0. So the constant C1 has to be 0. So the first answer what we get is C1 0. Now let us apply the second boundary condition. Y of 2L comma t. Y of 2L comma t equal to 0. So this is the second boundary condition. Y of 2L comma t 0. So again take the correct solution. In this put x equal to 2L. In the place of x we have to substitute 2L. So C2 sin P into 2L will be sin 2PL into this term. And already since we got C1 0, the first term will be 0 here. So equate that to be 0. Because the condition says y of 2L comma t equal to 0. So when we equate this to 0, don't touch the variable term. And we need to equate C2 as 0 or sin 2PL 0. But since already we got C1 0, if C2 also becomes 0, then the entire answer y of x comma t will become 0. If you see this correct solution, C1 0 and C2 both are 0 means the entire answer y will be 0, which is actually called a trivial solution. But we do not need a trivial solution. We need a non-trivial solution. So sin 2PL has to be 0. And we know that sin n pi 0, this is the famous formula we have, sin n pi 0. So comparing sin 2PL 0 and sin n pi 0, we have 2PL equal to n pi. So from here we have P equal to n pi by 2L. So this is the second result we get by applying the second boundary condition. Now let us apply the third boundary condition, dou y by dou t at x comma 0 0. So for this we need what is dou y by dou t. So we'll write the correct solution now again. What is dou y by dou t? Differentiating this y with respect to t. So don't touch the x term. C2 sin px, because C1 already we got 0. We are not writing that. Now differentiate the t term with respect to t. So cos, when we differentiate, we get minus sin pat into pa. Sin pat, when we differentiate, we get cos pat into pa. So this is dou y by dou t. Now in this dou y by dou t, we have to put t0. X comma 0 means t coordinate has to be 0. So when we put t0 here, sin 0 will become 0. Cos 0 will become 1. So this is the answer of the second term. And the condition says this has to be 0. So when this has to be 0, we shall not touch the sin px term because it's having variable. And already we discussed C2 cannot be 0. And since p and a are fixed parameters, we should not touch them. So what has to be 0? This C4 has to be 0. So the third condition is C4 is 0. So totally we have got 3 results. Now one more condition is pending in the boundary condition, that is the fourth condition. But when you look at the fourth condition, it is not 0. It is a non-zero boundary condition. See, we applied condition 1, condition 2 and condition 3 because they are all 0 boundary conditions. Now, before applying fourth boundary condition, since it is having a non-zero value, we have to generalize the solution. So what is the meaning of generalizing a solution? So since condition 4 is non-zero, we need to generalize the solution. So let us now see how to generalize the solution. For that, take and write the 3 results what we have got so far. First we got C1 0. Second application we got p equal to n pi by 2l. Third application we got C4 0. So taking and writing all these and substituting these values in the correct solution. Now this is the correct solution. Substitute C1 0, C4 0 and p equal to n pi by 2l. You have like this. So the first term will be C2 sin in the place of p. You substitute n pi by 2l. Second term C4 becomes 0 and C3 cos in the place of p. You substitute n pi by 2l. And now the C2 into C3 we should generally write as Cn. So this is the meaning of generalizing. C2 into C3 we should write as Cn, and we should give values for n from 1 to infinity generally. So this is how we have to write. C2 into C3 we need to write as Cn, and we have to put a summation for all values of n equal to 1 to infinity. So this is known as the generalized solution or most general solution. Now in this most general solution we have to apply the last boundary condition. Y of x comma 0 is f of x. Now what is y of x comma 0? In the place of t we have to put 0. So this is y of x comma t, the latest current solution. In that put t equal to 0. So where we have t here. So in this t when we put 0, cos 0 will become 1. So this is the answer of y of x comma 0, which is going to be f of x. And what is that f of x? We have f of x as, previously we had f of x as, this is f of x and it's an algebraic equation. So we need to compare this with our half range sine series. So remember, this is our half range sine series, sigma bn sin n pi x by l. So is it not the same form? Here instead of bn we have cn and instead of l we have 2l. That is the only difference. And hence the formula for cn will be the same formula of bn, but in the place of l we need to write 2l. So the same formula, wherever l we have, we can write 2l. And so this is the formula, and 0 to 2l we have to substitute f of x. Since f of x is bx by l from 0 to l and b into 2l minus x by l from l to 2l, we split the integration like this. And how to integrate this? We are all familiar in integrating whenever we have product of two terms using Bernoulli's law. So keep the first, integrate the second, minus differentiate the first, integrate the second. Using that formula, we can integrate the two terms, and after integrating, apply the limit L to 2L. First is 0 to L. So using these basic values of sine, cosine, everything, we can substitute the limit and we can get the answer for Cn like this. 8b sin n pi by 2 by n squared pi square. Now this answer of Cn substitute in your most general solution, which gives the final answer of the displacement of